This is a short video lecture series on waste management. One category under waste management is how do we deal with pharmaceuticals in terms of disposal. More than half of Americans take 2 prescription medications, and 20% of Americans are on at least 5 prescription medicines. The number of people taking prescription drugs has increased to 48% in 2007-2008 from 44% in 1999 to 2000. We're definitely seeing an increase in the percentage of people that are taking prescription drug medications. So the question is, how do you dispose of these medications properly? There's actually a law that was passed in 2010 called the Controlled Substance Act and Secure and Responsible Drug Disposal Act. This regulates how prescription drugs are supposed to be handled and disposed of in a proper manner. The proper disposal of prescription drugs and pharmaceuticals is a concern because we have done studies across the nation where we're starting to detect actual pharmaceutical drugs in our streams and our water supplies. I'll talk more about where these drugs are getting into our streams and water supplies and how that's happening. So one way to get rid of your prescription drugs is to drop them off during a National Prescription Take-Back Day, which is typically publicized to the community, and you'll have information available as to where to take your pharmaceuticals for drop-off. The other option is to call your local DEA call center at the phone number that I've put on the screen, 1-800 number, or you can click the link that I've provided, and that will allow you to put your zip code in, which I've already done. And then it shows me the local ones nearby. So here you put your zip in and it does a quick search and it tells me the phone numbers and the locations and the hours of where I can drop these off. One's a health center at Messiah College near us, and then there's 2 police departments that you could go to drop off the prescription drugs. So your local police stations have real simple bins that you can just drop your prescription drugs off of at free of charge, and it's a safe way to dispose of these medications in an environment where kids can't get a hold of them, and it's also a good way to keep your information private and completely anonymous as well. In Cumberland County alone, which is near Harrisburg, Pennsylvania, there are 22 locations that have these bins and are available for people to do their drop-off of prescription drugs. If you look at the Camp Hill area, there's about 36 prescription drug drop-off locations within a 20-mile area. And then finally, there's over 690 locations in the state of Pennsylvania alone. So there's definitely opportunity to drop these off for proper disposal. Please also keep in mind, if you're dealing with anything that involves syringes or any kind of injectable medication, such as insulin, anything that contains sharps or needles, they cannot be disposed of in these collection receptacles or in a mail-back package. Instead, they need to be taken to a drop-off location. On this side of the slide, there's a table that lists the various pharmaceutical and personal care products that are being detected in drinking water samples. And this was a study that was done at a university research center. So they're finding carbamazepine, DEET, nicotine, paroxetine, acetaminophen, which is for headaches, caffeine, antibiotics, tobacco products, and more, as well as insect repellents and mood stabilizers. So these are items that are currently not regulated by law in terms of permissible levels in streams or even in drinking water. And we're not even certain what the full potential health effects could be from these being in our water supply, or what the ecological impacts are going to be as these items biomagnify or bioaccumulate up the food chain. So this graphic just shows how pharmaceuticals can end up in our streams and rivers. First of all, you're dealing with production at a pharmaceutical facility, and they develop and manufacture drugs to market and sell, and that's about a $300 billion industry based on 2009 data. Then the distribution centers are the hospitals and the pharmacies and the retailers that sell prescription or over-the-counter drugs. At this point, people utilize those prescription medicines or over-the-counter drugs, and then they have to make a choice. If they dispose of them properly, the customers return the unused drugs to pharmacies or through various safe disposal and mail-back programs or national take-back days. In 2009, over 450 tons of pharmaceuticals were collected during three national one-day events in that year. So that's a lot of pharmaceuticals. Remember, I said that the person utilizing the pharmaceutical has a choice regarding disposal. They can dispose of them properly, or they could dispose of them improperly and either put them in the trash or flush the drugs down the toilet or down the sink. And the risk with this is that they could be found and used illegally by others, or they can enter local water supplies. Currently, there's 22 states that have introduced drug take-back legislation as of 2009, and these take-back laws require proper pharmaceutical disposal. Now, when you take the medications, there is the possibility that some of the drugs pass through the liver and the kidneys and basically pass through the person that's taken the medications and ends up in the toilet. That toilet is flushed, and it's either going to go to a private septic system where it's definitely not treated for any kind of pharmaceuticals. So whatever is being taken by the people living in the home will be discharged into their drainage field within a certain distance of their home, and that potentially can leach down into the groundwater system and contaminate the groundwater system over time. Most people that live on private septic systems also have private wells, and they live in a potential neighborhood. So what you're flushing down your toilet could potentially be contaminating your neighbor's well. Now, if you're not on a private septic system and you're on a public sewer system, then the toilet flush and anything else from your house regarding washing dishes or laundry is going to go to the public wastewater treatment plant. And here at the wastewater treatment plant, wastewater treatment plants can treat the wastewater to remove the organic material and the biosolids, but they are not set up to remove pharmaceuticals in any shape or form. So basically the pharmaceuticals just flow through the wastewater treatment plant and then end up getting into our streams and rivers at the discharge point where they basically discharge the treated wastewater. The other option for how this stuff is released into the environment is livestock and poultry. If they're taking antibiotics or if there's any pharmaceuticals being used for the livestock, then the manure from the livestock and poultry has to be stored somewhere. And if it's not stored properly and there's rainfall and there's runoff, then the potential is that anything that these livestock were exposed to from a pharmaceutical standpoint can get into the local streams and rivers. In addition, if you take that manure and you land apply it to a field for fertilizer purpose, then again, easy access for runoff from a rain event into the local streams and rivers. So those are different ways that it can get into the streams and rivers. And then now we're going to take water from the stream and pull it into a water treatment plant and treat it before it's distributed to people to drink. Well, at a water supply plant, the water is filtered into drinking quality water, and it has to meet the guidelines of the Safe Drinking Water Act before it can be distributed to the public. However, we do not have any Safe Drinking Water Act standards pertaining to pharmaceuticals or residual pharmaceuticals. So whatever treatment's going on at the water supply plant, it's highly unlikely that any of the treatments will remove the pharmaceuticals that were in the original source water, whether that's surface water in streams and rivers, or even groundwater. So studies have recently been done to investigate this, and 80% of 139 streams sampled in 1999 to 2000 contained at least one pharmaceutical. So a majority of the streams that were sampled back in 2000 had one pharmaceutical. Now the concentrations are at the parts per trillion level, often thousands of times lower than what the prescribed doses are. But the concern is, even if they're at the parts per trillion level, how are they being absorbed by the phytoplankton and the zooplankton, and how are they working their way up the food chain in terms of bioaccumulation or biomagnification. In addition, this was a stream sampling event. Trace of pharmaceutical chemicals and hormones have been detected in drinking water at 14% of the nation's water supplies, and 41 million Americans in 24 major metropolitan areas are consuming water that has pharmaceuticals in it. One specific area is related to Philadelphia, and they tested their water supply and found 56 pharmaceuticals or byproducts in treated drinking water, including medicines for pain, infection, high cholesterol, asthma, epilepsy, mental illness, and heart problems. 63 pharmaceuticals or byproducts were found in the city's watersheds, meaning in the streams and rivers. So they found 63 in the streams and rivers, and they found 56% in the water that was treated, 56 pharmaceuticals in the water that was treated, that was distributed for drinking purposes. So this is definitely a topic that needs further research and study. The best solution to it is dispose of these properly. Put in place manure management practices that stop the release of pharmaceuticals in the environment from fertilizer application. Maybe put into place some kind of a treatment technology that might be able to remove it from sewage, or put into place some treatment technology that would be able to remove it at the water supply plant scenario. This is a map depicting pharmaceuticals in drinking water. If there's a red dot, it means that the water supply that's distributed to the community tested positive for pharmaceuticals. If there's a green dot, it means that the water supply distributed to the community tested negative for the pharmaceuticals, and there's a few white dots where the test results are pending. So notice we definitely have more red dots distributed across the United States than we do the green dots. Now, as far as Virginia Beach, pharmaceuticals were found in the source water, meaning the stream or the river from which they were getting the water from, or maybe even the groundwater, but not in the treated water. So something was occurring in the water treatment process that was removing the pharmaceuticals. Also, in Austin, Texas, where the test results are still pending, the drinking water here was tested for only one prescription drug, a synthetic birth control chemical. So it does give you a pretty good idea that across our United States we are facing a dilemma with the fact that pharmaceuticals are showing up in our streams and rivers and even our groundwater, and that we're tapping those sources for water supply, and it's going through our water supply treatment system and being distributed directly to people. Now, please understand again that this is at the parts per trillion level. And I want to be very clear in letting you know that pharmaceuticals are considered to be emerging contaminants of concern. Let me say that again. They are considered to be emerging contaminants of concern. We've been studying them from the year 2000, so about 17 years worth of research, and we're trying to figure out how to handle this and address it in terms of resolving that there's no exposure through water supply, as well as no exposure through our ecosystems in our streams and rivers.